I wanted to kick off a multi-part series about AI hallucinations. AI is everywhere, across the globe, both in personal use, organizational or company-wide use, and I'm fascinated by this concept and this phenomenon really of AI hallucinations specifically. So I wanted to dive into some detail, some depth of what they are, how to spot or detect them, how they occur, as well as different mitigation strategies or tips as you use it day to day. We can't change or stop the AI innovation revolution, but we can work together to secure it and find ways to be responsible in its usage. And that's something I'm incredibly passionate about and kind of the basis of this fascination with AI hallucinations. How can we be able to trust the AI systems that we're using personally or in our organization? They are giving factual information back to us when we're interacting with them. To me, that's going to become paramount as this takes over more and more processes and handles more and more of our day-to-day lives. Okay, so AI hallucinations, what is it? A hallucination in a LLM or a large language model is when that AI model outputs something that is factually inaccurate. It can be a convincing but nonsensical or fabricated output. I know when I first heard that definition of convincing but nonsensical or not rooted in fact fabrication, there's a few humans that came to mind rather than AI systems. But that's what we're talking about with AI hallucinations. We're talking about outputs that are non-factual, nonsensical, or fabricated. They just are made up completely. And I really want to dive into how that happens. A huge root cause of this is just the nature of AI generation. Hallucinations are the inherent outcome of the probabilistic nature of LLMs, which are designed to predict the most statistically likely next word or phrase in a sequence, rather than giving it its factual accuracy. And it's important to highlight the difference between an AI model error and an AI model hallucination specifically. For instance, if you were to ask an AI, who is the president of the United States today in 2025, and it were to output Barack Obama, that would be an error, but most likely a result of a lack of an update to the data set that it was trained on and not stating Donald Trump as the current president. But if it were to output something made up, such as, Harrison Ford, although he's played a president, that would be more of a hallucination rather than just a model error. So that distinction is important as we dive into more of these details, that the hallucination is specifically that made up, fabricated portion of an AI model. The complete eradication of AI hallucinations is probably not likely based on the probabilistic nature of AI generation. But it's great to be able to focus on acceptable risk and effective mitigation strategies or management strategies with AI usage, and to create realistic expectations for AI capabilities and an organizational or personal application. This is why I'm so interested and fascinated by it, is I don't think it's going to go away completely, but if we understand what it is and specifically how it occurs, it can help us in our usage of it. Okay, let's dive down deep and get to the root cause of AI hallucinations. Why do these LLMs, these large language models, go off script? There's various reasons. We're going to look at a handful of kind of the big, broad, main categories. I think it often is discussed where if you're on the engineer side of it, you look at it and you say it's the user prompts. People don't know how to interact with these. If they're the user, you look at a hallucination that happens to you and you go, oh, this model's junk, and blame the engineer, kind of back and forth that way. I think, as usual in life, it's somewhere kind of right down the middle. And honestly, both sides affect the possibility and the causality of a hallucination. And often when we talk about hallucination, we're talking about textual hallucinations. But hallucinations can happen in imaging or visual hallucinations, like an autonomous vehicle could project a shadow and interpret it as a person grinding to a screeching halt. Or there could be medical systems or even security systems that could discern what's known as false positives. Most of what we're going to discuss and most of the interaction you might have as an individual would be on the textual side of it, the output text that's generated and hallucinations that are discovered and discerned from there. They're predicting the most statistically likely next word or phrase rather than verifying the facts specifically. It's almost like it's logic at its core, almost mathematical. The first category we're going to look at is that model development side of things, or what I like to call technical issues, technical difficulties. LLMs are fundamentally probabilistic. They're predicting the most statistically likely next word or phrase rather than prioritizing or focusing on verifying the facts. They prioritize fluency and pattern completion over that factual accuracy, meaning that they can occasionally confidently fabricate details even when lacking reliable knowledge. It's like they want to solve the next part of it. It is that prediction part of the model where they are trying to anticipate the next word. It makes me think of the SNL skit, which I find hilarious, Garth and Kat.
Do you guys even have concerts coming up?
Yeah, we do actually.
We do. We're performing
and we're
live.
going to be performing at the
arena
for the amphitheater of summer fun and playground time in the park.
And it could be that it doesn't have enough reliable information, right? So that's obviously a matter of the training, the development side of the model. But the model could have the appropriate and accurate information to output, but produces a hallucination instead because of that pattern part of it as it was developed. The pattern of what it recognizes and predicts to be that probabilistic output can be fabricated and hallucinated even if it has the correct information within its original data set. Complex model architectures, particularly deep neural networks, can identify patterns or relationships that don't exist in the real world, which causes it to produce plausible but fabricated outputs. Another factor from the model training or model development side of things is randomness in text generation. In the text generation process, especially when the model prioritizes learned knowledge over contextual clues, it can contribute to hallucinations that occur. We'll talk a little bit more of this in a different category, but that's where vague prompts can make that even more of a possibility, that randomness even more so, inviting the model to kind of make it up as it goes based on the lack or incorrect contextual clues. So again, it can have the correct information to output and to reply and answer the inquiry, but based on its training, it prioritizes that probabilistic nature over the actual learned knowledge. One other key thing here to highlight on the model or training side of it is algorithmic or technical factors. Some AI algorithms, especially in natural language processing NLPs or natural language generation, they can have limitations in understanding context or determining meaning, which can create hallucinations. So that's on the model side of things and that development side of things. Additionally, even once the model has been developed, they can be subject to adversarial attacks, which can manipulate the input into the AI to cause hallucinations in the output by exploiting system vulnerabilities. So especially for models that do that prioritization of learned knowledge over contextual clues, you can be subject to injection attacks or tampering within the learned and training data of the model to maliciously and intentionally cause hallucinations. Which leads us to our next category, the data-related issues that can cause hallucinations. It's all about the data, the quality and nature of data used to train LLMs, as well as data inputted for the LLMs to work off of, profoundly influence their susceptibility to hallucinations. What does that mean? It means data quality matters. I think of this like you are what you eat, right? That expression. I recently restarted a workout routine. It's been probably over a year, maybe closer to 18 months since I've had like a consistent, reliable workout routine. Guess what happened during that time? I gained weight. Why? Because I did not limit what I ate or the quality of what I ate for someone, especially that was no longer working out. If we want to have accurate inputs, we have to limit the AI's diet to accurate inputs. People often exclaim about AI, AIs have bias. And yes, that is an issue that needs to be addressed. But I like to point out the fact, why do you think that is? AIs have bias because humans have bias. And so the AI is going off of the human implemented bias and just perpetrating that. So quality, the content or sufficient information to complete the prompt, and even the format, like spreadsheets converted to plain text, greatly impact whether an AI model will hallucinate based on that data quality or perhaps the lack thereof. Another issue related to data quality or data issues is conflicting documentation. Within an enterprise, within your organization, there can be conflicting internal documentation, such as multiple versions of a policy or knowledge base, which hold contradictory answers and can cause the model to merge or confuse those facts, resulting in inaccurate outputs or even hallucinations from that. Generative AI models, especially those that might be based on transformer architectures, use kind of a process to capture context by assessing the significance of various words within an input sequence. So it's kind of like a prioritizing of specific words or weighing things a little heavily, but out of order. So even models with rich data sets, ones that have the necessary data, can rely or weigh immediate textual context and get too narrowed of a focus, prioritizing words that are kind of immediately adjacent or close in proximity within the input or your prompt during the generation process. Instead of drawing on its full range of knowledge, it kind of just gathers those that are quick or nearby. Instead of learning from the whole factual data set, it's just going off of that. So again, that's the data side of it that is affected both by the training side and the model development side of things, but also you as the user and how the prompts are worded lead greatly to whether or not the model might hallucinate because of that propensity or nature within certain models to kind of more heavily weight certain words in that context or an immediate vicinity. One other factor within the data issues side of things is noise, just overly broad search results, especially in RAG or retrieval augmented generation systems, can kind of overwhelm the model with irrelevant text, making it struggle to differentiate, between signal and just noise or white noise. And that can potentially lead to hallucinations as well. Unclear and irrelevant data can gaslight the model just based on the cleanliness of your organization's data that's being inputted. So if you're just putting in stuff that's not properly formatted, not properly contextualized, you're just feeding it inaccurate information or you're feeding it incomplete information. And again, it will rely on that probabilistic nature to determine and fill in the gaps of the data that you give it if their data is not complete or is not clear. A majority apply to the development and the engineering side of AI or LLMs, but it does matter the quality of the information the model is trained and sustained on. Intelligent AI is possible from intelligent sources. Non-biased AI is possible from removing bias from sourced inputs. Clean documentation inputs and clear directions help lead to resolving or limiting hallucinations from the model itself. And that leads me into kind of our final broad category, you, the user, me, the user or prompt engineering issues. I like to think of this as operator error, right? The way users interact with LLMs through the prompts that they are putting in, the prompts that they are using, can inadvertently trigger hallucinations. This is the side of it that you or I or users, perhaps it's people that we oversee or manage, that was something that we can do about it, right? On our side of it. We're not AI engineers, we're not trainers. There's stuff that we can educate ourselves and others to help limit or reduce AI model hallucinations, specifically in the prompt category. So ambiguous or overly complex prompts like vague or unclear, excessively wordy, or complicated instructions can confuse the model, prompting it to make assumptions or, again, try to some form of guesswork or that probabilistic nature of trying to figure out what the heck we're talking about, right, as the user. And this increases the likelihood of generating inaccurate or irrelevant information. I've worked a little bit for a company in the data annotation side of AI, and basically you're given prompts that were used or just randomized generated and models and their outputs, multiple models, kind of comparing those and determining which has a better reply. And some of the prompts are things like, write me a short story about a guy named Carl. Well, it's based on my friend named Steve, but we're going to call him Carl in this story. And Steve in real life is 6 foot, but for the sake of this story, he's 5'8", and stuff like that. That's way overcomplicating the prompt and providing a bunch and just a ton of irrelevant information can produce outputs that have irrelevant information or lead to guesswork where it just goes off of what's inputted in there. Back to the organization side of it, that's why it's important on that data quality to make sure that the documentation or things that you're inputting into AI, if within an enterprise situation, is clean and makes sense. It's limiting the AI model from having to guess, really. How users interact with AI models and the parameters that we set during output generation also influence hallucinations. It's important how users interact with AI models and the parameters set during output generation because they do influence hallucinations. One of the things I hope is a big takeaway from this video, and was for me when studying, is that probabilistic nature of AI. It's always going to try to end the phrase. It's always going to try to fill in the gaps and come up with an answer, right? So one of the things I've done to try to increase the factual nature of the outputs I receive is I go into the settings or I go into the customization and I state something to the effect of, if this is not factually substantiated, please return an I don't know output. And that helps me when I do receive that, and I do receive a lot of them because I do that in the settings, but it helps me then reevaluate the prompts that I'm using or putting in there based on the fact that it's not coming back with information known. Especially in an enterprise type situation, a lot of time implementers will inadvertently encourage hallucinations by instructing the model to always produce an answer, even if it's not confident or lacks sufficient information. This prioritizes like a fluid user experience, but it prioritizes that over the factual accuracy and can lead to hidden or fabricated information. Another thing I learned about AI models is that they can operate sort of off of a temperature. So a lower temp, think the model produces more deterministic and focused responses. When the temperature is low, the model is more likely to choose the most probable next word based on training data, resulting in outputs that are more predictable, consistent, and factual. They're recommended in applications where precision, factual consistency, and reliability are paramount, such as document drafting, financial analysis, or even like medical diagnostics. The higher temp category of AI models are those that prioritize creativity, diversity, but also randomness. It's less predictable, but really focusing on the creative aspect of things. They're generally suited for applications where the primary goal is creativity and the factual accuracy might be a secondary concern, or where there's measures in place of human-in-the-loop systems to fact check the outputs. And both models, a lower temperature model, a higher temperature model, have positive application, right? If you are trying to be more creative, you want a model to respond, or you want a model that's suitable for that randomization, that fabrication. You kind of want it to fabricate the outputs, versus if you're strictly in a factual information gathering that you might want to disperse and you want to make sure that those outputs are accurate. That's that lower temp model. We might maybe make a video, I might make a video on that specifically, because I found that little deep dive rabbit hole incredibly insightful on the different temperatures and types of models in that regard. Lastly, I did want to get into, on the user side, or the user prompt created hallucinations, that jailbreak prompts. So these are maliciously crafted prompts that can exploit vulnerabilities in the LLM's programmings, or even in its configuration within your organization, causing it to bypass safeguards and generate unintended, harmful, fabricated outputs beyond its intended capabilities. This is something that we're seeing more and more in attacks based in AI systems, or in AI systems in use. And it's something to be aware of in the configuration. Like, again, this is a combination of the training side of it, the engineering side of it, and the user or the handling of it, both things working in tandem. So both on the training and the model development side of things, but also on the configuration side of things for AI use, whether it's you as a person or in the department or company enterprise that you use AI systems and tools within. Something to be aware of. I wanted to include kind of the chart here, or a table of the various types of hallucinations. These are the most common ones that you might see or that might be caused, and some different examples of that, from the factual, contextual, logical, intrinsic, extrinsic, contradiction, and unsupported claim type of hallucinations. I hope that this has been insightful for you. Again, one of the major takeaways I wanted to have from this are those things that you can do as a user to help prevent hallucinations from the AI tools and models that you're using, but also to understand how both of these things work in tandem between the model generation, the model development, and the training side of it, and the user and implementation side of it. All of these things, and many of these things at the same time, can create hallucinations within your AI tools or your AI generated outputs. And I think it's important, and kind of the basis of what I want to talk about with AI hallucinations is understanding what they are and kind of that how they occur.